Hi, in this tutorial I will show you how to manage a virtual key. As the most part of previous exercises, we can see a real use of the function. So, what is the need or the problem of the current project? So, just imagine to install the project in a unit and the terminal, like this, is in a place that is not protected. For example, in the wall of the meeting room, the corridor, and so on. May happen that somewhere any user can go there, start to play and with the terminal, press the keys. The user may find the secret key combination, enter PRG, in order to enter in the configuration mask, and so he could modify the configuration. He may enable devices not present, but this is the less important, less critical thing, but more important, could disable a device that is used. So, how to avoid this? I'm pretty sure that the first thing that you are thinking is a password. So we could add a mask where to place a password. Okay, something like this. So when you press enter PRG, instead to enter in the configuration loop, you can enter in the password mask, so the user must know the password in order to enter the configuration. But this is not, let's say, the final solution, because the problem is simply postponed. That is, the installer that knows the password could press enter PRG, enter in the password mask, insert the right password, and so enter in the configuration mask. But if in this moment he go away and leave this mask on the screen, anybody could go there and make a disaster like I told you before. So there is only one final solution for this. That is what is implemented in, let's say, in all electronic devices with a user interface, like the PC, smartphone, and so on. That is, after a timeout, that is, after a time of inactivity of the keyboard, the system shows automatically the menu mask, the main mask, or login, whatever else. So this is the exercise. We have to show the main mask after 1 minute of inactivity of the keyboard. Okay, how to do this? You know how to show a mask. There is the go-to loop or go-to mask statement. You know that the go-to mask or go-to loop can be executed when you press a key. But you know that in order to execute a key, PRG for example, you have to press a button. So there must be a finger that presses a button. But we can't use this for our purpose, because the pressure or the execution of the key must be done automatically, that is by the strategy. After the timeout, we have to press the key. So what we need is this. So normally a key statement is executed when a physical key is pressed, as I told you before. Sometimes, like in our exercise, it's necessary to execute a key according to the value of the variable, that is, according to the strategy, after timeout in this case. So in this case, we need of a virtual key. A virtual key is pressed, or virtually pressed, when a variable, according to the value of a variable, when the variable changes from 0 to 1. So not according to the status of a mechanical switch, but according to the rising edge of a variable. So here are the 3 steps we have to follow to manage a virtual key. First of all, we have to manage the variable that virtually presses the key. So the variable that must assume the value 1 in our exercise after the 60 seconds of inactivity of the keyboard. After that, we have to create a new variable and link it with key name and link it with a variable. And the last step, define the function of the key. But we have already seen several times how to define the function of a key. So let's start our exercise. Well, step number 1, we have to manage the variable. This in red is the trend of the variable we need. So till we press the keys, PRG, ESC, up, down, enter, and so on, the variable remains at 0. But after 60 seconds from the last pressure, the variable became 1. The strategy that we need is this one. There are other similar strategies, but the most used is this one. Well, I don't want to spend time to explain you how this strategy works, how in detail the block works, because the only new thing here in this topic is step 2, that is how to create a new key name and link it with the variable, because the variable and the function of the key is something that we have already seen. Step 1 are, let's say, simply strategy, like any other part of the strategy, and how to define the function of a key is something that we have seen several times so far. So I won't give you so many details, but in short, move is a very, very simple block, because move simply copy the value of the input into the variable connected to the output. In this strategy, this block will write 0, where into the variable key pressed. Not is a block that we already seen before in the exercise of the hitting. While delay is a very basic timer. It is an atom block. It simply creates a delay between the rising edge of the output from the rising edge of the input, as the icon states. The time is expressed in seconds. The enable is almost never used, but for details regarding all this block, you can refer to the online manual. envk go-to main mask is a user variable that you can call as you prefer. The new thing is key pressed. What is key pressed? Key pressed is a system variable. So, as told you before, variables like this are called user variable, because you define the meaning, the name, envk, and so on, the meaning, request to press the virtual key, whatever else, memory type, data type, limits, and so on. While for system variable, all those properties are predefined. Here is the list of system variable. When you click S in the variable list, the system filters the variables by system. S stands for system variable. There are a lot of variables. Currently they are about 350 or 400 grouped in a few categories. Typical system variables are the one regarding the clock. But in general, system variables are variables that are used to communicate with the BIOS, that is the operating system. They are used to have information regarding the system, or vice versa, modify the behavior of the system. So, as I was telling you, there are a group of system variables called current something, current day, current hour, current minute, and so on. So all these variables returns the hour, minute, day, month, and so on, read from the real-time clock. So you can see that the meaning, that is the hour, the name, current hour, the memory type, RAM, data type, integer, and so on, are delimited also. They are predefined. These variables, for example, are used to manage the scheduler. For example, switch the unit on in the morning and switch the unit off in the late afternoon. Other very used system variables are pico type. Pico type returns the type of controller. For example, pico type, in this moment pico type is 1. This means that 1 is pico 1. So in this moment the simulator is simulating a pico 1. Something similar is for board type. Board type returns the model, small, medium, large, and so on. So these are very used because the project runtime can know on which model of controller is running. For example, if it runs in a small Pico 5 compact, the program could enable only one compressor. While when run in a Pico 5 or Pico 5 Plus or bigger controller, can enable 2, 3, 4 compressors. Other very used system variables are the ones regarding the protocols. All them start with COM. For example, COM baud rate are used to define the speed of the serial port. COM protocol to set the protocol used in the serial port. CAREL protocol, Modbus protocol, and so on. But we will see them in a specific exercise. So let's go back to our exercise. Before I mention key pressed. Key pressed is very simple, one of the most simple system variable, because it detects when a key is pressed. So the key pressed takes the value 1 when any key is pressed. Let's see it. Key pressed. Key pressed, start simulator. You can see now that in this moment is 0, but as soon as I press a key, it becomes 1. Okay, I can reset manually, press another one, click, now it is 1. Click, it is 1. So it simply detects when we press the key. So maybe that now this strategy becomes more easy to understand. So key pressed, so when you press a key, this variable becomes 1. Since it is 1, it resets the timer. This is 1, this is 0, so it is ready to detect the rising edge. This block we write 0 in key pressed in order to reset that variable. So in the next program cycle, key pressed is 0, the output of the note is 1, the block detects the rising edge, and if you do not press again a key, after the time, 60 seconds, the variable becomes 1. If in this period you press again key pressed, you press again a key pressed becomes 1, 1 resets the timer, and so on. But I repeat, it's not important that now is clear how these 3 blocks works. Anyway, you can take your time and study the block in order to fully understand how the strategy works. So let's create that strategy. I told you that we need of a move bx. B is for Boolean, means that the output must be a Boolean variable. X is for RAM memory, so the output is a variable in RAM memory. And you can see that there are all other combinations. After the move, we need a not. After the not, delay, here is. And then we need the key pressed. Okay, the only way to place a system variable in the strategy is drag and drop from the variable list. You can't double click and drop down the list here. Okay, I have already placed the variable. I remember very well the strategy, so I go fast. No, I want to use 60 because I don't want to wait 1 minute to test the function. Till I test this function, I use 5 seconds. When everything works, I will change back to 60. Finish and then create a variable, enable VirtualKey to mask. I repeat that this is a user variable, so you can call it as you prefer. RAM memory is good, boolean is good, only output is good, everything is good. Finish. Okay, everything is done, so we can test this first part. You can see that this strategy is exactly this one. Same block, same variable, same connection, okay, except the time, but okay, everything is the same. So I repeat that we expect a trend like this. So while we press the variable is 0, after 60 seconds, 5 seconds in this moment, the variable should become 1. After that, if you press again a key, the variable became back, change back to 0, and everything restart. Let's see if the strategy behaves as I just told you. Start. Maybe you remember that with the I we can see the value of the output. So press, and you can see that doesn't work. The variable remains 1. I know that. So the question is, but why, if even if the strategy is the same? Why, if the strategy is the same, then this one doesn't work? I'm sure that these blocks are the right blocks with the right connection, right variables, and so on. So why doesn't work? So if the problem is not the variable because we used the right variable, it's not the constant because we used the right constant. It's not the output because I told you that you can use any type, any name for user variable. Are not the connection because I used the right connection. Let me delete. And the problem is not the block because we used the same block. So what is the difference between the strategy that works, the one in the slide, and the strategy that doesn't work in my project? You can see that the only difference are the numbers. So the only difference are the numbers over the block. They are important because let me stop. No, we are already in editing, because they defines the block execution order. In the very first exercise, I told you that the blocks are executed one after the other, and then they restart. So when you power on the controller, it executes all the blocks that are here in the task main, or one block after the other, and then restart. Well, this number defines the order the blocks are executed. You can see that in this project, the one that doesn't work, the sequence is 210, 220, 230, while in the strategy that works is 30, 10, 20. What is important here is not the absolute number you use, but is important the relative order, because the blocks are executed according to the ascending order. 1, 2, 3, 4, 5 till 9999, that is the maximum number. So in this strategy, this block is the first of this group that is executed. After this is 20, this one, after this 30. So the first, the second, and the third. While in the strategy that doesn't work is 210, 220, 230. So this is the first, second, and third. So the difference in general is this block. In this strategy is the first of the group, in the other is the last of the group. And this is very important. This strategy can't work because since this block is the first of this group, this block immediately writes 0 into key pressed, this variable. So if the variable was 0, okay, remains 0. If it was 1, it is forced to 0. So for sure, the other blocks will always see the variable 0, because this forces to 0. Since this is 0, this is always 1, this is always 0. This block will never detect the rising edge of this, and so it can't work. The right sequence is this one, and this block must be the last of the group. Something like, okay, double click 240, for example. So when if you press a key, this variable becomes 1, this one writes 0 in the output, this block triggers the internal trigger, and after this block resets the variable. So after, not before. Well, there are other things to say regarding the block execution order, but we will see them in the next exercise. For now, the important is that you change, or I change, the number of this block, these blocks, in order to have this block with the lowest number of the group, this in the middle, and this as the last block. So double click 240, okay. Now we can test. Okay, start simulation. Now the variable is 0. So if we press and we continue to press, the variable remains 0. This is correct. Now I stop. 1, 2, 3, 4, 5. The variable now is 1. Restart to click. The variable changes back to 0, 0, 0, 0, 0. Stop. 1, 2, 3, 4, 5. Okay, works. 0, 1, 2, 3, 4, 5. Well, so the variable works exactly as we expect, according to this trend. Okay, step number 2. is to create a new key name and link it with a variable. As told you before, this is the only new thing of this topic. Well, we are talking about keys, so the way to create a new key is, as we have done before for the key combination, is here in the key list of the terminal editor. I remind you that if you don't see the key list, is because you have pressed this button. So right-click. In previous exercise, we have selected the new key combination. Now we have to use a new virtual key. Here we have to write a new name for a key. Name like this, alarm, PRG, ESC, and so on are predefined key name. Now we have to create a new name. It is a username, so you can call it as you want. I will use it the same name there is in the slide. VK for virtual key, go to main mask. The variable that virtually presses the key is the variable that we have just created. envk, go to main mask. Description is optional. Virtual key for return to menu task after 60 seconds. Okay. There is another property here that is the key code. What is the key code? Key code is this. You can see that each key has a name and a code. Here the point is that when you press a key in the terminal generates a code. For example, when you press this key, the terminal generates and sends to the controller the number 12. Doesn't send a string like alarm, but 12. Since it would be difficult to write here key 12 do something, because the user should remember what is the purpose of that key, the editor allows you to assign to each key code a name in order to use it here in the key function editor. So here you will write key alarm do something, not key 12 do something. Well, also virtual key requires a code. The question is, but what are the code that we can use? Okay, if you click question mark, you see what are the key code that are used and free. You can see that the key code from 1 to 15, as you can see here, are the single keys. From 16 to 135 key combination. There are some reserved, there are some keys for the built-in, for example. Just to simplify, we can see that the unused key code that you can use for virtual keys are in the range 137 to 179 and so on. In fact, you see that the system automatically shows the first three unused key code. So in general, you have just to type, to leave that key code and go straight to add. And here is, I think I have clicked cancel instead of OK, so I try again. VK. Okay, I have rewritten everything. Add. Okay, next time it works. Here is the new key name. If you scroll the list, you can see that it is a virtual key because there is a variable assigned to it. So when this variable becomes 1, the system presses this key exactly as when you press sorry, to shorten. Exactly as when you press the switch number 12, it executes alarms 5 PRG, okay, and so on. Step number 3, we have to define the function of the new virtual key. As told you before, it is not something new because we have done that at least 3 times before. So the new key has to show the main mask. We know how to show a mask, go to loop or go to mask. So click the ground. Remember the ground for the global. Click the mask for the mask. Click the field for the field. Since we want that the function of a key is executed regardless where is the cursor, which field and of which mask, we have to place the code at global level. So select the key, VK go to main mask, control space, GO, arrows, enter, open, control space, L, dot, enter, dot, loop main, close, semicolon. In short, it is exactly the same code of the kiosk. So this step has been very simple, so now we can test the whole exercise. Start. So till we press the keys, nothing happened, but when we stop, 1, 2, 3, 4, 5, here is the main mask. Okay, press, stop, 1, 2, 3, 4, 5, here is the main mask. So I can state that the exercise works. So now you know how to execute a statement like go to loop according to the strategy instead of according to the finger, let's say. Now, before to forget, I want to change the timeout back to 60, or maybe also more than 60. So what are other typical use of the virtual keys? We can see that statements that we can use here are send SMS. So if you want to send an SMS when an alarm occurs, for example, you have, as usual, to follow these steps. We have to manage the alarm variable, and in one of the next exercises we will how to do it. We have to create a new virtual key specific for that alarm, and then the code is correspondent to that key is send SMS. Okay, now I don't want to go in detail about this. Another example, how is possible to show the next mask automatically every 5 seconds. For example, imagine that the terminal is behind a glass of an electrical panel, where only the service has the keys, so can enter, open the door and press the keys. So how the end user can see what is the value of temperature, cooling status, heating status. So now you know how to do this. We have to create a variable with a trend like this, where every 5 seconds becomes 1, and then link the variable with this trend to a new virtual key, and the new virtual key executes the statement go to next field. If you remember, go to next field is go to next mask. We have seen this in previous exercise. Here is. Another typical example is enter in the alarm mask or in the alarm loop as soon as an alarm starts. Okay, this more or less is what I told you before. Okay, that's all also for this exercise. Thank you for watching this tutorial.